Welcome to today's deep dive. When we think about digital workspaces, we tend to imagine them as inherently pristine.
Oh, yeah. Totally sterile.
Right, like it's all just electrons and memory allocations.
Yeah.
We assume that because we aren't dealing with physical materials, we aren't running a carpentry shop with sawdust piling up or a kitchen with grease everywhere, that our dev environments are just immune to physical clutter.
Which is, of course, a complete illusion. I mean, anyone who builds complex systems knows that digital spaces get incredibly messy.
They really do.
State leaks, side effects accumulate, you write a script that interacts with the file system, and suddenly you're leaving a very real, very persistent footprint behind. And often, dealing with the friction of that digital mess, it forces you to fundamentally rethink the architecture of your workflow.
Exactly. And you see this dynamic perfectly captured in our single source for today's session. It's an excerpt from a developer's journal titled Notes on Haskell Programming, Part 141. It's by an author named Ang, and it was published today, actually, May 21st, 2026.
Right, fresh off the press.
Yeah. So our mission today is to unpack how a seemingly mundane programming annoyance, literally just a lingering file left behind after a test, leads to this profound shift in software design philosophy. We're going to track the journey from a messy, imperative workflow to a beautifully clean, declarative solution.
It's a brilliant case study, honestly, because it starts at the lowest possible level of a code base, just a single unit test. And it scales up to one of the most important architectural debates in software engineering. And, even if you aren't a Haskell programmer, the logic here is universally fascinating.
So true. So let's get right into the mechanics of Ang's initial problem. Ang is building an ebook converter and naturally is writing automated tests to ensure this converter actually works.
Right, you have to test it.
Yeah, and the text notes that Ang made a deliberate choice to stick with integration testing for now, rather than mocking the results, which makes complete sense.
It does, because if you're building software that outputs a complex binary format like a PDF or an EP, asserting against a mocked interface is, well, it's practically useless.
Okay, let's unpack this for a second. Is mocking the results kind of like testing a recipe in your imagination, whereas integration testing is actually baking the cake?
That is exactly it. You can do the nutritional math on a recipe in a spreadsheet all day long, but you can't verify the cake without baking it. You have to force the software to do the actual work. You feed the converter raw text, and it must output a real physical PDF file to the disk so your test can actually inspect it.
But, baking the real cake inevitably leaves you with a dirty kitchen.
It sure does.
And the consequence of Ang choosing integration testing is the physical mess it leaves behind. The process generates a real PDF file, and that file gets left behind as a lingering artifact right in the project's root folder.
This raises an important question, though, about how developers balance the need for realistic testing against the clutter it creates in their workspace. The project root folder is your workbench. If every single test run drops a dummy PDF there, you're actively polluting your workspace.
You end up with all these untracked files swamping your version control. It's a nightmare.
Right. It forces the developer to constantly manage that state.
And the text outlines Ang's initial workaround for this messy root folder, which was just manually removing the generated PDF files after each and every test. The source explicitly defines this manual workaround, all the step-by-step file creation and deletion, as imperative testing.
Yeah, imperative testing, it's the most natural human reaction, right? You make a mess, you write a script to clean it up.
But wait, I want to play devil's advocate here for a second. Deleting a file takes, 2 seconds? Why is this manual cleanup actually a trap? Why does Ang view this as a problem big enough to require a whole refactor?
Because it introduces extreme brittleness. When you use an imperative mindset, you're telling the system exactly how to do every little chore. Step 1, allocate the file. Step 2, run the converter. Step 3, assert the size. Step 4, delete the file.
Okay.
But the flaw reveals itself the moment that perfect sequence is interrupted. Tests aren't designed to pass, they're designed to fail.
Right.
So let's say Step 2 encounters an exception, and the test runner panics. The execution halts immediately. That means Step 4. The imperative command to delete the file, it never runs.
Oh, wow. So you're left with the lingering PDF anyway.
Exactly. The exact mess you wrote the script to avoid. Telling a system exactly how to do a chore makes the system brittle, and that scales terribly. Imagine a pipeline running hundreds of tests. If the runner crashes and fails to clean up, you start leaking state everywhere.
Yeah, the next test fails just because a lingering file is causing a naming collision.
Precisely. It's a fragile way to build a workflow.
That makes total sense. So let's look at the refactor. Aang realizes this imperative cleanup is a trap, and instead of manually deleting the artifacts, Aang decides to let the program generate them directly within the operating system's temporary directory.
It's a seemingly simple change, but it's massive.
Let's walk through Aang's actual Haskell code snippet from the text just to see how it works. The text highlights a specific line, tpdir runio get temporary directory.
Right, so that's a critical maneuver. By using runio get temporary directory, Aang is safely querying the environment. It's basically asking the operating system, hey, where is your designated sandbox for a volatile state?
And the OS hands back a path. Then Aang routes the test input there. The text shows the path setup as tmpdir testinput.txt, and then the test simply describes the action. It says describe convert to ebook and verifies that it generates a physical PDF file and returns the correct path.
Notice what's missing there.
The teardown step. There's no command to delete the file at all.
Exactly. The cleanup logic is completely gone.
Here's where it gets really interesting. Think about this in real-world terms. The old imperative way was like cooking in your own kitchen, where you have to manually scrub every pan. But this new method, it's like switching to a magical hotel room that automatically cleans itself and vanishes the next morning.
I love that analogy. What's fascinating here is how leveraging built-in OS environments like temp directories eliminates the need to manage file cleanup manually.
Because the OS itself handles it.
Exactly. The operating system has built-in garbage collection for temporary directories. It routinely flushes them out. So by writing the files there, Aang isn't just hiding the mess. Aang is relying on an asynchronous system explicitly designed to handle abandoned state.
Keeping the project workspace completely pristine.
Right. It completely decouples the creation of the mess from the cleanup of the mess.
Which brings us to the climax of this deep dive. Because Aang's ultimate takeaway from this code change elevates this from a simple file management trick into a high-level discussion about resilient systems.
It really does.
By moving away from imperative manual steps, the test code becomes declarative. According to the text, declarative testing simply states what is the expected result.
And Aang concludes that because of this shift, the test codes are now much cleaner and resilient.
Cleaner and resilient, those are the key words.
So what does this all mean? How does the simple act of using a temporary directory magically transform a test from imperative to declarative? If we connect this to the bigger picture, an imperative system is obsessed with the process. It forces you to define how the system achieves its state. But a declarative system cares about the outcome.
The expected result.
Right. It defines what the final state should look like, and it trusts an underlying system to handle the tedious chores. Aang's test basically says, I declare that a PDF will exist at this specific path. That's it. It completely abdicates responsibility for how the file is eventually garbage collected.
And that directly results in that cleaner and resilient code Aang talked about. It's cleaner because there's no teardown boilerplate.
And it's resilient because it's indifferent to failure. If the test crashes halfway through, it simply doesn't matter. The partial PDF is sitting in an isolated temp directory. The OS will sweep it away eventually.
So you get all the benefits of integration testing without the fragility of manual cleanup.
Exactly. You stop writing scripts to manage state, and you start writing declarations.
It's just a brilliant shift in perspective. Let's briefly recap the journey we took today. We started with an ebook converter and a messy root folder caused by integration testing. We watched Aang move from that tedious manual imperative cleanup to a sleek declarative solution using the operating system's temporary directory.
And it resulted in beautifully clean, resilient code.
It really did.
So I want to leave you with a final, thought-provoking question to mull over in your own life. We've talked about Haskell and file systems, but this friction exists everywhere. Where in your own daily routines or workflows are you stuck doing tedious, imperative manual cleanup?
Oh, that's a great question.
And how could you redesign your environment to be more declarative? How could you set up systems that naturally handle the mess for you so you can just focus on the results? Think about it. Thanks for joining us on this deep dive.